is Bettina and I'm a senior data scientist working at the BBC. Today I'm going to talk about developing a recommender system for a public service organization, and more precisely I'm going to talk about the project I'm working on with BBC Sounds. So let's start with a quick introduction. So I've got a background in statistics and economics, and I joined BBC and BBC Data Lab about 3 years ago. So what's BBC Data Lab? So our mission is to develop and deploy machine learning at scale. So we're currently focusing on recommendation engines across multiple BBC products. And we want to help users find content they love while discovering content they didn't know they would love. And we do all of that by making sure that we comply to our BBC editorial values. So as a public service broadcaster, we've got a set of values. Trust is the foundation of the BBC. We are independent, honest, impartial. The audiences are also at the heart of everything we do. Our mission is to inform, educate, and entertain, and we do that via our huge amount of diverse and creative content. So we've got lots of different BBC products. We've got iPlayer, sounds, news, sports, etc. We've got text, audio, video content. And on average, we produce around 2,000 pieces of new content per day. So it's quite a lot. Now, as I mentioned earlier, I'm working with BBC Sounds. So a little bit about BBC Sounds. So it replaced iPlayer radio, and it's focused on audio content only. So live radio, but also podcasts, music mixes. It's now available on web, mobile, and TV. And there are around 2.8 million weekly users and 100,000 pieces of content available at each moment. There exists already a personalisation fit that consists of 9 to 12 items, depending on if you are on web or mobile. And it's done by an external provider. But we do believe that we've got all the capacity to build everything in-house. And so that's what we're aiming to do with this project. So a few challenges with BBC Sound and recommendations is that there is a popularity bias towards an heritage audience from iPlayer radio, so people consuming more BBC4, The Archers, whereas our target audience is under 35, so young audiences. There are also quite a lot of one-timers, and as I mentioned previously, quite a lot of new content every day. So now that I've set the context, let's dig a bit more into the machine learning. So we decided to pick an hybrid algorithm that is well known and has been around for about 10 years, factorization machines. So factorization machines combine both collaborative and content-based filtering. So just as a quick reminder, collaborative filtering is based only on user item interactions, and it's something like customer reviewed this item, also viewed that item. Whereas content-based approaches relies on content metadata or descriptors, and it's going to be something like you may also be interested in this item. So the nice thing with factorization machines is that it handles the metadata and the user item interactions in the same way. An example of metadata that we're using here at the BBC can be the genre. So, for example, if the content is like music or news or like something factual, science and nature, etc. And the nice thing with factorization machines is that, contrary to classic collaborative filtering, new items can be recommended solely based on metadata. So this is very, very handy for us. The main downside being that it's quite hard to explain. It's a bit black box, so it lacks a bit of transparency. One of the key things in our approach is that we've got lots of editorial and product inputs. So the BBC has almost 100 years of editorial experience, and it's something super valuable. So we uphold our public service values by keeping human in the loop in like all the steps of our project. It's something really that is super important, like the collaboration we do with editorial and products. So a few examples. First of all, for the cold start, so when we don't know enough the user to do some personalization, we use some editorially curated lists. Also, we've got a set of what we call business rules that are automatically applied either before or after like the model predictions. And to, for example, to ensure diversity. So, for example, we are not going to recommend different episodes of the same series. We've got also some rules to remove some sensitive or outdated content. So we're not going to recommend like news that is more than 24 hours old, so stuff like that. So these rules are set by editorial and product and are like really super important. And finally, we're also building the BBC's machine learning engine principles. So this is a self-audit checklist that all the teams developing some machine learning algorithm that need to follow while developing them. So for example, we need to have a very clear documentation of all our data sources. Why did we pick this model and not another one? All the editorial decision, like everything must be recorded. Also, we need to make sure that we are involving a multidisciplinary team, so we can consider the need of all of our target audience. So these are like a few examples, but we've got really like a long checklist to follow while we are developing the recommender engine. And also these lists have been made in collaboration with editorials, so that's something that we're making like iterations of it as well. Now, how is the model performing? So start from the beginning, we knew that we wouldn't have any A/B tests in place anytime soon because the architecture was not available, was not ready for it. But we wanted to gather some explicit and early feedback. So what we did is that we put in place some qualitative experiments. So how does it work? We recruited some test users from our target audience, so under 35 years old, both editorial and non-editorial colleagues. And we showed to them two sets of recommendations. So one from the current provider and one from our algorithm, and they had to just select if they prefer one of the lists or if they like both or neither of them, and also explain why. It was super nice because we managed to gather some really like good explicit feedback on how we could improve the algorithm, but also more than 80% of these test users said that they like as much or preferred our algorithm. So it was quite good as a early feedback. One downside, obviously, is that it's something very time-consuming because it was super manual, and it's not possible to draw a conclusion for the entire population, obviously. So we've also got some metrics that we compute. So we've got some offline scoring metrics using historical data to compute some accuracy metric, but not only. So we really believe that metrics like recency, diversity, popularity are super important to consider. And again, that's something that we monitor with editorial and the product. So we will sometimes downgrade the accuracy to have more diversity, for example. So these metrics enable us to have a rough idea of the model performance, but we know that they don't like reflect the online behavior, and we know that online scoring is going to be like really like the way to compute the model performance, and it's going to be very soon in place. So hopefully next time we will give a talk, we will have some concrete results on this. Now, so I've been talking about machine learning quite a lot, but actually it's really not only that when productionizing recommender engine. So we have been working on this project for 1.5 years with only like 4 people, like 4 developers, like 2 data engineers, 2 data scientists, and we have been working closely together to build everything. So I've been working on the machine learning side, but not only. I've been also doing all like these engineering steps. So again, like collaboration is really key for us, and we think it's super valuable. So I'm not gonna go into detail of all of these steps because it will take me like quite a lot of time. But some of the really like important thing we had to do in terms of engineering was to configure all the infrastructure. We had to do all the data collection, all the data processing. We had to take care of all the serving side. So we built an API. We also are pre-computing our recommendation, and we're storing them in a Redis dump. We're also doing quite a lot of monitoring, and finally everything needs to scale. So really on this past 1.5 years, it was super engineering focus, but we've got really something quite powerful that is working now. So on the how, I'm just going to share with you the tech stack that we currently have. And when I say currently, is because like we're also learning the tool as we were doing the project. And so we went back and forth a few times, and it's likely that we're going to change also some of the tools that we decided to work on, because as I said, we're still learning them. But we are on GCP, so we're doing everything with Google tools. We use Python as our main coding language because that's something that we share between scientists and engineers. And most particularly for the model, we're using the LightFM library. It's super handy because there is this dataset class for like some of the pre-processing, and also we can parallelize stuff, so it's very nice. We are using Apache Airflow and Cloud Composer for all the workflows orchestration for all our pipelines. We're using Apache Beam and Dataflow for some data processing. And on this, we have lately had like some issues with like the cost and the time it was taking. So we're currently talking a lot with Google to see if we are using the tool in the right way, or if we are just like it's not like for our use case. So as I said before, we might just change technology very soon. As I said before, we're using Redis to store pre-computed recommendations, Kubernetes to run the API and also for all the CPU-intensive tasks, and finally Terraform for all the infrastructure. So now, just as a quick recap of my talk, some takeaway points. So AI in a public service organization brings unique challenges. So as I mentioned before, we've got a set of values, and we make sure that we comply to all of them, and that we've got human in the loop at really like each stages of the project. So it's super like this like collaboration with editor is very, very important. Secondly, machine learning is a small part in building a recommender system for production. So this is really true in our case because we decided to build everything from scratch kind of, and we're working like 2 scientists, 2 engineers developing this project. So I guess it depends on the trade-off, but for us, like it was really true. Like we didn't do a lot of machine learning. It was just it was engineering focus, engineering heavy. And finally, interdisciplinary collaboration is key. So on this note, as I mentioned, we've got the collaboration with Editorial and Product, but also with data scientists and data engineers. And of course, we've got lots of project management helping us to build this project, but we really think like it's the key of success. Thank you for listening to me, and let me know if you have any questions.